So in black, I'm going to draw what's happening. So we know that there's friction. So the forces that we have are friction. And then we have mg over here. And then we have the force of the wall. Then we have the force of the floor. We're going to call the normal force. So let's call this one wall normal force. Is that better?
Yes.
So wall normal force. So those are the only forces that we have. Are those the only forces we have?
Oh, I do.
All right. So let's set up a couple rules right now, just by looking at this. So we know that this thing is a static equilibrium. So we know that everything is balanced. So if the normal force of the wall is in that direction and the object's not accelerating that way, we know that there has to be another force that's of equal in this direction. So what force do you think that is? Yeah, the force of friction. It's the only one that's pointing this way. So we can say that the force of friction, can you check that I'm still in? Yeah. The force of friction is equal to the wall normal force. We can say that. Now, we know in the downward direction, we have mg, the weight, the force of gravity on the mass. So this thing's not accelerating downward, so we know that there has to be another force in the up direction. And what force do you think? The normal force. So we know that the mg has to be equal to the normal force of the floor. The floor normal force. So we know those things to be true. And those are forces in, that's just your regular net force. Now we need to talk about the torques. So, yeah.
Come in.
Come in.
We know the net torque is going to be 0. So that means you can just put all that stuff in that back table. The back table, right there. So we know that the torque to the left plus the torque to the right equals 0. So let's talk about what is the torque in either direction. I'm going to use Brandon's convention. So this comes from Brandon. It's not necessarily the right reason, but it's a good way to remember. So we're going to use it. So here's the angle. Here's the angle. And if we make like a triangle right here, that's cosine or sine? That's going to be cosine. And then this side over here is going to be sine. And if this were like two squares, because of two triangles, and because of alternate angles, we know that this angle must be the same over there. Where do you guys learn that? You learned that in geometry?
Yes.
But like, is that geometry or algebra 2 or
Geometry.
recap?
What do we call it?
So over here, this side would be cosine, and this side would be sine. So the way Brandon remembered this was that NG points towards the cosine, and wall of the normal force points towards the sine of the angle. So now we know that there are two torques. So these two torques, one's going to be positive and one's going to be negative, but they equal this. That means that their magnitudes are equal to each other. So I know that my torque, my positive torque is going to be equal to my negative torque. In magnitude, in number. So let's figure out what the torque in the positive direction is. So what is the torque? What is the force that's pushing it in that direction? That's making it rotate this way. The wall. Because the wall is the thing that's gonna, if I push it this way, make that positive. So so it's R, F, sine of the angle. Instead of F, the F in this case is the wall normal force. And then the R, again, the R is the distance from where the force is to where the axis of rotation is. So where's the force? And then a straight line straight to where it rotates. That's your R, which in this case is going to be the whole length, which they tell us is, let's just say it's L. So I'm going to put L as my R, and then this one's going to be sine of the angle. So that's the torque acting on that side. Now the torque on this side, RF sine of the angle, which again, so what's the force that's causing it to rotate this way? Not the force of friction,
The MG.
the mg. Because if that wall wasn't right here, what would happen to that ladder?
The guy can just fall.
It would just fall this way. So do you see how it would fall? It would rotate that way. So mg is the force that's causing the torque in the negative direction. So I can put mg. The r is going to be the distance from where it is.
1/2 L.
So 1/2 of L, because it's acting right in the center. On problem number 8. Hold on. On problem number 8, the ladder doesn't have mass. What's causing the torque is the guy on the mass. So however far the guy is on the ladder, that would be your R. So if the guy's 5 feet up the ladder, your R would be 5. Wherever he is. So 1/2 L, that's my R, and then my mg, and then not exactly right, but the way we're gonna remember it, it's gonna be to mg cosine of the angle.
This is the way that MG is pointed. ¿Será por la inch y dos?
No digas eso porque me confunde a mí.
Te pasas.
A mí
So-
eso me confunde.
I'll try to find something that will, there's like a reason why the triangle's right here. So- Now we know that this is true, so we can say this. L, I know that this is gonna be equal to that. 1/2 L mg cosine of the angle. So I pretty much just worked out number 6 for you. No, because how do I move it?
Oh, yeah.
So the question was like, won't this be negative? Well, no, how do I move this over here? How do I cancel a negative?
You add it.
You add a positive. So if I add a positive to this side, it cancels. What you do to one side, you have to do to the other. So now we have positive on this side. So we know that this condition must be true. We know that this condition must be true. And we know that this condition must be true. So now these three conditions have to be true, and now we can solve for all kinds of stuff. Because we know the next problem they ask us how to find the angle, right? So what do you guys notice? We can cancel out immediately.
O sea, el
Yeah, you can cancel the L. So now I get WN sine of the angle equals 1/2 mg sine of the angle. But what can I put instead of wall normal force? What can I can plug in friction. What's the equation for friction? The coefficient times the normal force, and right here the normal force is equal to the weight. So I can rewrite this as, couldn't I rewrite that as L U mg sine of the angle?
So you cancel mg.
So I can cancel out the
Wait, Did you
mg,
cancel L?
and then the L's also canceled out. So you can
And
solve
then you
for
have the coefficient.
and they give you the coefficient of
And then the
friction.
angle you have to-
Exactly. You have to solve for the angle. You're solving for that. That's what they're asking you on the next problem.
And you should-
That's also how you do, and that's the setup for number 8. That is also the setup for number 8. So that should be 6, 7,
You go try.
and 8 for you right there.